Introduction. This video will take you through the process of designing a solution to a problem. In the programming project, Unit A453, you will be presented with a series of programming challenges. The first stage is always to read the whole task sheet through carefully. You might want to make some notes about what you have been asked to do. You will probably tackle each task one after the other. These tasks become progressively more complex, so it is very important that you know exactly what is required in each case. Analyse. The best way to analyse what is required is to produce a set of success criteria. You can then use these to test against to make sure that your programs do exactly what is required. Double-check against the task sheet to make sure that you haven't forgotten any. As you work through the list, think about how you will get from the start to the finish of the program. It is rather like putting together a shopping list of ingredients for a cake that you'd like to bake. You can write the programs using any language that you choose. Of course, this should be one that you know and that best fits the requirements. You should explain why you have chosen this language. Design. You need to think about what the user will input into the program and what the program will do with it. Some programs only require text-based input. Others will need to respond to the user clicking controls on the screen. So we'll need a GUI, graphic user interface, such as Scratch or Visual Basic. If the user is inputting text, you will only need to think about the prompt needed. If your program uses a GUI, you will need to design the layout. This should be easy for the user to use and contain all of the elements required. If there will be more than one screen, you will also need to create a navigation system to move through them. For a text-based program, output may be simple or might need you to think about formatting so it is easy to read. The next step is to design the algorithm needed. You can do this by using a flowchart or by writing pseudocode. If you are drawing a flowchart, keep it as neat as possible. Run through the program in your head using your flowchart to make sure that your algorithm is correct. Pseudocode consists of English-like code not written in any particular programming language. The advantage of this is that your algorithm design could be given to a programmer of any language and they would be able to understand how you wanted the program to function. Data. Data in your program will need to be temporarily stored in variables, but multiple values might need to be stored in a list or array. Choose suitable identifiers for your variables and data structures that indicate what they are used to store. This data type must be suitable and you should justify why you chose it. You may also need to write the data to a file. Arrays are very useful when you need to write to a file. The program may also need to read data from the file into the program, so you will need to store it in an array there too. All of these decisions will need to be thought about when you design your program. Testing. The final item to design is how you will test your program against the success criteria. The best way to do this is to produce a test plan. This should cover all of the criteria and state what test data you are going to use. As a rule, you should not only test your program with correct, valid data, but you should also test values which are on the upper and lower boundaries and invalid data that should be rejected. To give an example, if you asked a user to enter their age, entering a word rather than a number would be invalid. So would entering nothing at all. A valid entry would be, say, 15. If you needed the age to be between 14 and 16 years, you should also test with the upper and lower values to make sure that the boundary values are handled correctly. Final words. When you start a project, you might be tempted to dive in straight away and not want to spend time designing it. This isn't a good idea because you might take many wrong turns with your program before you get it right and this may take a lot longer. Also, your program may not do what is required. This is why the design stage is often the most important when developing any project. Good luck!